Today, we'll be looking at a full workflow for printing a dedicated seat cushion for our mini Moto. We'll cover from scan to CAD to modifying the internal structure using Materialise Magics software for printing with flexible ATA resin on the Formlabs Form 3 SLA 3D printer. The scan will encompass the full top cover of the bike, around 600mm in length, so the medium object size suits us best here. Since there are some small holes on the seat area which need to be captured for fitting, we can choose the fine detail setting. Balanced output and no colour scanning were chosen to give the best scan quality within a reasonable time frame. Here we start scanning, and you can see the targets being recognised by the scanner immediately. The part is positioned on a turntable for ease of rotation, allowing all surfaces to be captured easily. Placing targets on the vertical faces of the part allows for tracking to be maintained when the scanner is held parallel to the base plate and enables capture of the undercuts in the model. The model is glossy plastic and scanning spray has not been used here, so you can see some small areas of noise due to reflections off the shiny surface. These will be cleaned up shortly. Keeping the scanner at its optimal focal length will create the best scanning results. Green areas indicate this on the display, while red and blue areas indicate that the scanner is too close or too far away from the model. Next, we remove the turntable and background from underneath the model by simply picking out the base plate. Then remove the noisy patches by selecting only the area of the scan we wish to keep. To improve the scan quality, we will take a second scan and merge the results. In this case, only the top surface is of interest, so we can scan the part in the same orientation as before. The same cleanup steps are followed, and the scans are merged automatically using the targets on the model. Seeing the mottled surface shows that the meshes intersect, a good sign for two merging scans. Alignment is not necessary here, so we'll leave the model as is. Next, during the improve stage, we can tidy up the mesh using a range of tools. Returning to the parameters menu, swapping to a normal detail level smooths the surfaces, paying less attention to slight irregularities in texture, while maintaining the holes we wanted to capture in sufficient detail. The same improvement tools are available in the Peel.CAD software, so we'll make further improvements here. We can see the bolt holes are elongated from wear and tear, so we'll tidy these up to be circular. We use the brush selection tool to select mesh triangles surrounding the hole and then remove these from the mesh. We can then use the edit boundary tool to fit the boundary to a circle. To smooth the seat surface, we will use the sandpaper tool to remove lumps and bumps, upping the smoothing strength and brush size to speed up the process. This will make the selection of the desired area simpler in the next stage. Finally, the mesh is cleaned to remove any isolated patches and outcropping triangles that may be left over. Next is to select the face to fit the new seat around. The sudden change selection tool allows this to be done simply due to the sharp lip at its edge. The selection area can be increased to fill the desired shape, and any missing areas can be patched in with the brush tool. The selected triangles are copied and isolated from the main scan. The outer boundary is edited to fit a smooth spline around it, rather than being left with jagged edges. The curve tension can be adjusted to tighten or loosen the spline as desired. We will be projecting a silhouette of the face onto a flat surface to extrude from in our CAD software. So we'll create a plane roughly parallel to this face. The silhouette tool is used to project the boundaries of the copied surface onto the plane, and the resulting curve deviation can also be adjusted here if required. The entities are transferred directly into SOLIDWORKS and can be extruded right away. Here we create a thin base and a thicker extrusion which is intended to form the padded part of the seat. Ensuring these features are not merged allows the bodies to be treated separately in Materialise. Once imported into Materialise as a step file, we can access the structure generator. Selecting no outer shell means that our structure will be exposed rather than being hidden by external walls. The medium thickness pattern is chosen and scaled to 10mm in all directions. Hit finish, and in a few seconds our structure is produced. Printing on the Form 3 in flexible ATA resin leaves us with a part which springs back to its original shape. Using different thickness choices within Materialise allows this property to be modified, giving a firmer or softer cushioning effect. Thanks for watching, and see you soon for more Scan to CAD tips and tricks.